Welcome to 33rd lecture in the course of Industrial Engineering and Operations Research. We are discussing linear programming. In the last lecture, I discussed graphical method for solving linear programming problem. Graphical method is effective if there are maximum two variables. More than two variables, we cannot use graphical method. So therefore, some other method has to be used, and very popular method is simplex method. It is called simplex method. So this method we will be discussing in detail today. Now best way to understand this method is by means of example. So I am taking some simple example. That is, problem is maximize z is equal to 2x1 plus x2 subject to 4x1 plus 3x2 smaller or equal to 12, 2x1 plus x2 smaller or equal to 4, and x1 plus 2x2 smaller or equal to 6, and x1, x2 both are greater than 0. So although I have chosen such type of problem which can be solved graphically also, but I will explain the simplex method. Now this is objective function, and then you can say that I have got three inequality constraint and they are less than or equal to type, and plus there is a variable bound, that means upper bound on x1 and x2 is infinity, and of course the lower bound is 0. So variables are bounded between these limits 0 and infinity, okay, because x1, x2 greater than or equal to 0, that means their value can be any positive value. So in one sense this is also constraint, but we call it a variable bound. So let us try to solve this method using simplex method so that we can understand it properly. I will try to go slowly and explain you each and every step. It is a very simple method. So as a first step, I am writing these constraints in the standard form. Objective function is okay, maximize z is equal to 2x1 plus x2, but constraint was 4x1 plus 3x2 is smaller or equal to 12. So if I add any positive quantity, but I don't know what is that variable, let us say it is s1, then it becomes equal to 12. So this inequality can be converted into equality by adding s1. This is called slack variable. There was some slackness there, I have added that. Similarly, 2x1 plus x2 is equal plus s2 is equal to 4. S2 is also a slack variable. x1 plus 2x2 plus s3 is equal to 6. S3 is also a slack variable, and x1, x2 greater or equal to 0. These s1, s2 and s3 are slack variables, okay. So this one, so by that, and of course we have got objective function as you have seen, maximize z is equal to 2x1 plus x2. So we can say z is equal to 2x1 plus x2 plus 0s1 plus 0s2 plus 0s3, because we have added these but they are not having any value. So that's why this is the objective function. Now if you see that when I have done in this way, I have got basically three equations, okay. These are three equations and they are equality type, and we have got x1, x2, s1, s2, s3. That means we have got basically here also I should write s1, s2, s3 greater or equal to 0. This is also must be written that this is. So we have got 5 variables, okay, because these are the basically 3 equations, but we have got x1, x2, x3 and we have got 5 variables. So what we can do that, if we put, suppose we fix up that, let us say that if we make 2 variables 0, say for example I made x1 equal to 0 and x2 equal to 0, then I can solve for remaining variable, because 3 equations, 3 unknown, that makes this one. But here we have got 3 equations but unknowns are 5. So there is a lot of flexibility, that means they can take any value, that means it is underdetermined system of equations. We have got 5 variables but we have got only 3 equations. So what we should do, that we fix up the values of 2 variables and then we can solve for remaining one. So if we do like that by making say 2 variables 0 and solving for the remaining variable, then whatever solution we get, that is called a basic solution. There can be many basic solutions actually, that I have told you. So anyway, not going into that much. So but what happens, that what type of basic solution we should choose to start with. So if we have got the slack variable, so very convenient way is that if I put x1 equal to 0, x2 is equal to 0, let s1 should be equal to 12, s2 should be equal to 4, s3 should be equal to 6. That means entire right hand side value, and then it will become very easy. So slack variables provide a convenient mean to find out a starting basic solution. That is the beauty of that. So now for doing the computation, it is better to write in the form of a matrix or in the form of a table. So we make a table type of thing. We say, suppose this is just a basic column, you can say basic variables are put here. Of course Z is not called basic, basic is S1, S2, S3, but I just have written that. If you want, you can say that Z is basically other thing, okay, that Z is not the basic one. You could have said this is the column S1, S2, S3, and we say that this is Z, just written that x1, x2, s1, s2, s3 solution, and I am just putting a column of ratio that I will explain you. So first Z equation was what? Z was 2x1 plus x2 and other values were 0, 0 s1, 0 s2, 0 s3, okay. So therefore it becomes minus 2x1 minus x2. We can, if we put in that way, then it becomes minus 2x1 minus x2 and minus 0 s1 minus 0 s2 minus 0 s3 is equal to 0. So we have convention of writing it like this: 1 minus 2 minus 1, and this coefficient becomes 0, this is 0, this is 0, and is equal to 0. This is the convention. And now S1 will be written as 0 because Z coefficient is 0, because S1 equation, that means that equation in which S1 is there, okay. So that I am writing that 4x1 plus 3x2, 4x1 plus 3x2 plus S1 is equal to 12. So this is 4, x1's coefficient is 4, this is 3, below x2 3, then S1's coefficient is 1, then S2's coefficient 0, S3's coefficient is 0, right hand side means solution is 12. And similarly I should say about S2, this is 0, this is 2, this is 1, this is 0, this is 1, this is 0, this is 4, and this is 2. Then this is 0, this is 1, this is 2, this is 0, this is 0, this is 1, this is 6, this is 6, okay. So this is also, so S3 means, let me just write that S3 value equation in which S3 was there, this was x1 plus 2x2 plus S3, so is equal to 6. So I am putting those things, that Z coefficient is 0, so just 0, x1 is equal to 1, x2 is equal to 2, S1 0, S2's coefficient is 0, S3 is 1, and this value is 6, and this. So now what we do that actually, after we have written this much, okay, let us not talk about ratio till now, up to this much. This table is also telling me that right now S1 is 12, S2 is 4, S3 is equal to 6. This is a solution, this is a basic solution, also it is a feasible. So this is called basic feasible solution. So this is called basic feasible solution. So we have got a basic feasible solution. Now we have to decide that can we replace it by another basic feasible solution which will be better. So since our objective is maximization, so we see that here x1 is equal to actually 0, and x2 is equal to 0. That's why solution is also 0. So if I increase the value of x1 by some amount, and maybe I reduce or eliminate some variable s1, s2, s3, anything I remove, then that solution may be much better. So which one should, so we decide that some variable can become entering variable. This is entering variable. So should I make x1 as entering variable or x2 as entering variable? So you see that x1's coefficient is 2. That means if I increase x1 by 1 unit, my z will increase by 2. But if I increase x2 by 1 unit, z will increase by 1 only. So therefore, what we can do that here, that you have to do that, decide that x1 should be the entering variable, because then you will get more advantage, because x1's coefficient is high. In terms of here I am saying x1 coefficient is high, but the way I have written, I would say that the most negative coefficient is taken as entering variable. See, most negative coefficient is -2, so this is as entering variable. Now we have to decide that which should be the leaving variable. Should I remove S1, should I remove S2, should I remove S3? So first of all, this column, that x1 column, can be called as pivot column. So we can say pivot column, and then we have to decide that which can be leaving, that is called pivot row. So here the rule is that in each row you see the coefficient in the pivot column, like here in S1 it is 4. So and this side solution is 12. So divide 12 by 4, it becomes 3. Okay, so this is basically 12 by 4. Similarly, in another S2 row, x1 is equal to 2. So you do 2 by 2 is equal to, this is 2 but it is 4. So rather 4 by 2, that is 2. And similarly here the solution is 6. So you do 6 by 1 and this becomes 6. Okay. So this is how that it becomes entering variable. Okay. So now among these, minimum value is of this one, that is 2. Okay, minimum 4 by 2 is 2. So therefore minimum is this one. So therefore S2 becomes leaving variable. Leaving variable. We have to take minimum, and suppose you get infinity or you get negative value, then you should ignore that. Then you should not, you among the non-negative values, non-negative finite values, whatever is the minimum ratio, that has to be taken. So therefore S2 has been decided that S2 will be the leaving variable. So this row becomes a pivot row. We can say S2 becomes pivot row, and this of course crossing of pivot row and pivot column becomes maybe pivot element. You can say this is 2. And what we do that here, so what we have to do here, that suppose this is pivot row is there, so I decide that this is should be leaving. That means in S2 place I will put x1, and it is 0, 2. So x1 coefficient is 2, but I will divide whole thing by 2, so that this becomes 1. So this becomes 1. This is half. Whole row is divided by 2, half, and this becomes 2. And this of course is right now it is ratio, so this is 2. So this way we will normalize that thing. Then next what we will be doing, that next we will be above that, in that column all the coefficient of x1 I will be making 0. Okay, in other places. Okay, so what happens, suppose z row is there, so in z row it is -2, but here the x1 coefficient is 2. So you, this row, x1 row is multiplied by 2 and straightway added to the z row. Z row is often called in the books, it is called reduced cost row also. So you can understand, and in some places they write in slightly different way. This one zj minus cj, but okay, leave that. I am just telling the way it is done in the book of Taha, and it is simple. Theoretical concepts may differ, means way of presenting the theoretical concepts may differ from book to book. Anyway, so suppose you have x1, multiply whole thing by 2 and add that. So 1 into 2 is 2, so this becomes 0. and this is half. So, this is half this one. So, this will become 0, this will become 0 2, this is 0 only, this will become 1 and this will become 0 and this is 2 2 ja 4. So, this is 4 like that. Similarly, you have to subtract that type of thing. No, S1 here, the coefficient of x1 is 4. So, multiply whole thing by 4 and subtract. So, this is 4 into 1, 4, 4. So, this becomes 0. Then 4 into 2. So, this becomes 1 and this is 1 only. This is 4 into 2. So, you subtract minus 2 and this is 0 and this is 4 2 ja, so this becomes 4. Okay, that type of thing has come, and here you have to make coefficient of x1 0 in S3 row also. So, this becomes 0, just subtract the whole thing just like that. This is 3 by 2, this is 0, this is minus 1 by 2 and this is 1 and this is 2 and this is 4. Okay, so like that you have to do that. So, let us see that we get a neat and clean that another matrix. So, this is after first iteration we have got a neat and clean matrix or table like this: Z 1 0 0 0 1 0 0 0 1 1 minus 2 0 and 0 1 half 0 like that. So, now we see that there is no negative coefficient in the Z row. So, that means we can conclude that we can, of course, we have obtained an optimum solution. We can conclude it here, and then table itself is telling me what are the values. Value is x1 is equal to 2 and x2 is equal to 0 because there is no table in this one. Of course, slack variables are there, S1 and S3 is values are there. S1 is 4, S3 is equal to 4. If S1 is 4, that means that constraint is inactive, because for active constraint slack variable will be 0. So, therefore, and Z is equal to solution is 4. Even we can do by this one also. Z is equal to, what was Z is equal to? This was 2x1 plus x2. So, therefore, what happens? 2x1 plus x2, and now since x1 is equal to 2, so 2 2 ja 4, 4 plus 0 is equal to 4. So, therefore, Z is equal to 4. So, now although we have got a solution, but there is a border case type of situation that okay, x2's coefficient is not negative, but it is 0. So, if we want, we can consider that suppose x2 becomes entering variable and decide that some other variable can be the leaving one. So, what will happen? So, we can do that type of thing also, and we can obtain an alternate solution. So, if we have got two solutions which are alternate, so therefore, general solution can be written as general solution of x1 x2 will be alpha times one solution, say 2 and 0, and 1 minus alpha times another one corresponding solution, and this alpha will be between 0 to 2, 0 to 1, okay, 0 1, alpha is between 0 and 1. So, this is what that this method can be done. So, if we get that exercise right now, I am not doing, you can do and complete that. Rather, I am telling that one thing, that how it is like that, supposing in an LP problem, two optimal solutions x and y exist. Why I am writing x and y like a bold? That means x means vector. Okay, so maybe that x is maybe x1 x2. Similarly, if there are 4 variables, then that also will come. So, bold means it is a vector. Suppose x and y exist. Prove that 1 minus p into x plus py is also an optimal solution if 0 is smaller than p is smaller than 1. So, now how to solve that? So, objective function of LP is Ctx. I am writing that. How? Objective function z is equal to c1 x1 plus c2 x2 plus c3 x3 plus cn xn. But you can write it like this, that you can say that this is Ct into x. And now here, because C means basically C1, C2, and you can say up to Cn. So, Ct becomes row vector of the coefficient x becomes x1, x2, xn. So basically in the compact way this is Ctx. So C is the vector of coefficient. Let us assume that the optimal value of objective function is V. So in view of x and y being the solution, Ctx will be equal to V, Cty will be also equal to V, okay, because both are the solutions. So Ctx is equal to V, Cty is equal to V, both will provide the same objective function values. So if I multiply the first one by 1 minus p and second by p, then I can write it 1 minus p and this is p, and then I can take, this is linear, so Ct I can take common and I can say 1 minus px plus py, and this becomes basically I can write 1 minus p and then it can become Ctx, okay. So we multiply it by this one. Suppose I multiply 1 minus p into v here this side, and I say that p into v multiply by p. So this summation again becomes v, and this side I can take Ct common and I can say 1 minus px plus py. So therefore Ct multiplied by this thing is also v. So therefore we can say that 1 minus px plus py also provides a solution whose value is same. So therefore this is also a solution. But why we say that it has to be, but p should be between 0 and 1, because it should not cross the feasible region. But whole thing is that because it is a convex problem, in the convex problem if x and y are feasible, then 1 minus px plus py is also feasible. This can be shown, and I also told that because if one point is there, another point is there, then any line joining these 2 points will contain all the points in the feasible region. This is the property of a convex set or convex hull. We have got a convex type of shape. So therefore this type of situation will be there. So this will be, so provided p is between 0 to 1, this condition will be there, that 1 minus px plus py will also be feasible. So as long p is between 0 and 1, then we can say that of course 1 minus px plus py is also a solution. So we have got infinite number of solutions, many solutions between two solutions x and y, and this is what has been given. So now let me just make you more confident. Let us consider the another linear programming problem. Maximize z is equal to 2x plus 4y subject to x plus y plus s1. S1 is a slack variable. X plus y plus s2 is equal to 4, and x1, x2, s1, s2 is smaller or equal to 0. Here already I have given in the standard form. That means my constraint would have been x plus 2y is smaller than 5, x plus y is smaller or equal to 4. Okay. So we solve the problem by simplex method. So we obtain the following table. Actually, if you solve that, solve the table, so you see that 0, 0, 2, 0, okay, 0, 0, 1, and this is 1, 0, minus 1, 2, and 3. So now if we have got some table like this after solving, then carry out one more iteration and make S2 as a basic variable to obtain another solution. Okay, so this is what happens, that here this is this is one. So suppose we can say that this is one solution, suppose you have got, and in this x is equal to 3 and y is equal to 4. But if you decide coefficient of S2 is also 0, if you want you can do that S2 as a interim variable, although it is a slack variable, but I am introducing that, and if you do that, then you can obtain that another solution and you can actually get this one. So this is alternative optima. So identify the optimum solution. Okay. So therefore what we can do, that we can bring that, but what should be the leaving variable? This is minus 1. So 1 minus 1 ratio is absurd. We should not consider, but 3 by 2, okay, ratio. So that means if I take S2 as a pivot column, so 3 by 2. So that means by minimum ratio test, I will go to 3 by 2. Okay. So I will be taking that. Here I can say that this is S2 and S2 can become 3 by 2, but I have to divide that. What I have to do that in next step? In the next step, that I have to divide it by this one, everything by pivot element 2, that means this is by 2. So, that means 0 and this is what that I have to do that. So, this is S2 and this becomes 3 point this one minus 1 by 2 and this becomes basically this becomes 1. Okay. So, this becomes basically 1 type of thing 1 and it is 1.5 and then we obtain that and then we do that operation and in fact we also do that this one. So, you have decided to take S2 and then we have got X we got eliminated and then in the Y I have done something and you get this operation. So, this table you can complete and if we get one solution as xy is equal to 3 by this one. So, we can get another solution as 0 into 2.5. Okay. Here y is equal to 2.5 and because x1 is not there. So, xy is equal to lambda 3 by 1 plus 1 minus lambda 0 2.5 3 lambda plus 2.5 0 lambda. So, this represents all possible solution where lambda is basically 0 to 1. Okay. So, this type of thing can be done. So, similarly, so maximize if we have got 2x1 plus 5x2, x1 plus 3x2 is smaller than 40, 3x1 plus this is equal to this one, x1 plus x2 is smaller than 10 and then we obtain the solution. Here also we are following the same type of procedure. Okay, we are doing that. We have put, we made that here slack variables, we wrote x3, x4, x5. That means even you can say x3, x4, x5 instead by s1, s2, s3. So, we said that x3, but that is also slack variable and then we get one by one we keep doing that. We get another table by making that x3, x4, x5. So, that means x5 here x3, x2 has come because most negative coefficient. So, x2 has come into the picture and then by ratio test that means 10 by 1. So, that means it was minimum. So, this was taken out. Okay. So, this becomes this one. Okay. Now, similarly, we can have another problem. I am just giving very simple example just to make you very confident. Suppose I have only maximized w is equal to 4y. Here even two variables are not there. No? So, subject to y is smaller than 1 and y is smaller than 3 also I have given. It is very trivial problem, but here I have said y is unrestricted, means I am not telling y greater or equal to 0. So, this is not in the standard form, whether you want to do by simplex or not, but you have to convert into standard form. So, we can say that since y is unrestricted, we can say let y is equal to y plus minus y minus. Okay. And we can say y minus y plus, that is greater than 0, s1 s2 greater than 0 and subject to y plus minus y minus plus s1 equal to 1, y plus minus y1 y minus plus s2 is equal to 3, s1 s2 are slack variables. So, y1 y minus y plus s1 s2 greater than 0. So, basically one variable problem has become two variable problem, y plus and y minus 1 has come. So, let us make the first table, initial table, w, coefficient of y plus is minus 4. In fact, here I need not write a w column here, earlier I have been making, but that does not usually come into too much in picture. So, I am just telling y plus y minus and s1 s2 and solution. So, minus 4 4 0 0 and corresponding to s1 we have got 1 minus 1 1 0 1 and corresponding to s2 we have got 1 minus 1 0 1 and 3. Okay. So, this will go and this will be obtained like this and then basic variable will be y plus y minus s1 s2 solution So here what happens that in this most negative coefficient is of because it is maximization problem, so we see the coefficient of y plus, and that is minus 4. So what we do that here, which should be the leaving variable. Here if I divide solution 1 by 1, so this becomes 1, and this is 3 by 1 is 1. So minimum ratio is of 1. So that means S1 should be leaving. In place of S1 I should put y plus. Okay. So I have written y plus there, and then y plus coefficient is already 1. So I don't have to do anything to here. That means pivot element, this is pivot column, this is pivot row, but this coefficient is already 1. So we don't have to do anything, 1 minus 1, just write that. Only thing that above that in that column make the coefficient 0. So here it was minus 4. So that means I multiply this y plus rho by 4 and add in this. So this becomes 0, 0, 4, 0, 4. Okay. And here what should I do? Here it was already 0. So I have to do nothing. So I put 0, 0. So we get a, now I got this coefficient also 0, this coefficient also 0, and S1 is 4, S2 is this one. So from the table, now what happens that from the table we get y plus is equal to 1 and y minus is equal to 0, which gives y is equal to y plus minus y. That means it is 1 minus 0 is equal to 1. Therefore, the optimum solution is y is equal to 1 and maximum is w is equal to 4 into 1 plus 4 into 0. That means it is equal to 4. Okay. So maximum becomes this one. Maximum from here also it is obvious that w is equal to 4, and if I put in the formula, then also it is w is equal to 4y, then it is equal to this one. So this is how that it has been done. Similarly, there is another problem, maximize z is equal to 2x plus y subject to x minus y smaller than 0, x2x plus 3y smaller than 30. Again you put this slack variable x minus y plus s1 is equal to 0 and plus s2, and you can put that z is equal to minus 2, this is 0, s1's coefficient is this, s2 is this one, so s1 has come 0. So basic variable can be 0 also. Okay. That it is not that basic variable cannot be 0, and S2 has come 3. Now, but most negative coefficient in maximization problem is what? This is basically minus 2. So this becomes entering variable, and which will be 0. S1, 0 by 1 is 0, 30 by 2 is 15. So that means S1 can be the minimum ratio test. So this is 0 is smaller than 15. So S1 becomes leaving variable. So instead of S1, now put it is x here, and its coefficient is already 1. So we don't have to do anything, 1 minus 1, 1, 0, 0, 0. Only thing that you multiply this x row by 2 and add in the z row. So this becomes 0, this becomes minus 1 into 2 minus 2, and minus 2 minus 1 added becomes minus 3. Like that it has been done. And similarly S2, this coefficient also has been made 0. That means this x row multiplied by 2 subtracted from the S2. So this becomes this one 30, and therefore now what happens that this will be now still that most negative coefficient is y. So y becomes this one, and this is minus 1, 0. So this becomes 0, and this is 5 into 30 is equal to 6. Okay. So x we have already taken. So this is x. Okay. So this is x is basically equal to 0. So therefore here we should take as a y actually, otherwise we will just go in the loop like that. So therefore x was actually, it came from outside. So this is 30 here. So therefore I take it y, and this is 0, 1, and you do like that, and you get finally the solution like that. So z is equal to 18, and this becomes this one. We can do solve these type of problems by MATLAB also. In MATLAB there is a lin-proc function that can be used. You can practice it. This is maximize z is equal to this. So there is a way to give the input like coefficient a, that means it is lower bound and 0, and this is lower bound is 0 like that, and we can give upper bound also. We put that data and we solve that problem. You can read in the helpful file, and then we can complete that, and we can directly get the solution through MATLAB LinProg. Similarly, there are many other free software in the Google by which you can get the solution, but it is better to practice by hand the Simplex method, and for solving the big problems you can make use of this one ready-made software. Thank you very much. We will continue in the next class. Okay.